Hello everyone, welcome back to the lecture series of Building Estimate, how to calculate the quantities of different item of works. So student, in the first session of the lecture series of Building Estimate, we have learned about Introduction to Building Estimate, in which we have discussed about that we need to divide the entire building into certain components such as excavation, concrete in foundation, masonry in foundation, sand filling in foundation, then brickwork in superstructure, RCC slab, flooring, painting, plastering, and etc. Then we have discussed about types of structure. There were two types of structure: load bearing structure and frame structure, and we have already discussed that we are going to see numerical most often on the basis of load bearing structure. Then we have discussed about abstract sheet and measurement sheet, and we have seen the format of the abstract sheet and measurement sheet. Then we have seen the three methods for quantity calculation. There were three methods: centerline method, long wall and short wall method, which was already known as out to out and into in method, and third was crossing method. So we have discussed about three methods. Then in the just previous session, we have started discussing about center line method. In center line method, I am revising it very quickly, that what we were doing in center line method, that in center line method, we need to calculate total center line length of all the walls appearing in the drawing. How we can do it? The formula was into in dimension of wall plus half thickness of the wall from other side and half thickness wall from the other side. And if both the side the wall is of same thickness, we can add into in dimension plus one wall thickness. Then we have discussed about the scenario where there is one cross wall or two cross wall and having junctions in the drawing. There were two types of junctions: plus junction and T junction. For every T junction, we were deducting half breadth for each junction. Then, for every plus junction, we were considering it as two T junctions. Then we have seen the formula for net center line length. The formula for net center line length was total center line length minus half into width into number of junctions. So we have covered up the entire concept of center line method. If you are not aware about what is center line method, what is the formula, how it is being calculated, kindly go to the previous session or the first session of the lecture series of Building Estimate and clear the concept of center line method, and then come back to this session. So today we are going to see numericals based on center line method. Yes, today we are going to see some of the numericals based on center line method. So starting with the first numerical, very simple and very easy, let us see. So as you can see in the drawing that the plan and the section of a clinic is given. You can see in the drawing that there is a passage, there is a ward, there is a medical storeroom, there is a consulting room available in the plan. And just in the section, you can see that a step footing is given, and above ground level there is an RCC coping is given. In the section drawing, if you look at closely, the height is given at different points. So the bottommost part is suggesting the PCC having the width 750 mm. Above that there is a step footing starting. So the first step footing is of width 550, above that 450, above that 350, and then the wall of the medical clinic is appearing of having thickness 230 mm, and that 230 mm wall is continuous at superstructure. The various heights of the footing is given in the section drawing, and the length and the width, the basic dimensions are given in the plan. So I hope we are clear about the drawing. In the plan, the passage is 1.77 meter in width, and the door is having the same width. So the width of the door will be 1.77. The wall is of 3 meter by 6 meter. Now we have discussed that first dimension is horizontal, second dimension is vertical. Then the consulting room is of 4 meter cross 4 meter, and the medical store is 3.5 meter cross 4 meter. There are two types of door given in the plan, D and D1. The opening schedule of that doors is already given in the drawing. In the notation, you can see at the bottom part of the drawing, the opening schedule of doors is given. So this is about the drawing of which we are finding the quantity. Now let us look at the question. So the question is, plan and section of the clinic building is given in the earlier slide. As we have seen, find out the quantities as following: earthwork in excavation, PCC in foundation having ratio 1:5:10, masonry up to plinth, and RCC coping. So we need to find out the four quantity: earthwork in excavation, PCC in foundation having ratio 1:5:10, masonry up to plinth level, and RCC coping. But here in the question there is an additional information given. Let us read it carefully. Assume that the steps are to be constructed in 1:6 masonry and rest on 300 mm BBCC foundation below ground level. Yes, this sentence is trying to say that we need to assume that the steps which are we have seen in plan is being constructed by masonry and their foundation is made up of BBCC below the ground level. So I hope we are clear about the drawing and we are clear about the question. So starting with the first quantity, which is earthwork in excavation, all we need to do is to multiply length, width, height and number. But we are calculating this sum by center line method. So the first step of center line method, if you are calculating any type of numerical, the first step will be to find out the total center line length. Now we already know that what is total center line length. So the total center line length is sum of all the center to center distance of walls in horizontal direction plus sum of all the center to center distances of wall in vertical direction. So in our case, let us look at for vertical direction. So as you can see in the drawing, the vertical direction, the first is ward. So for ward, the vertical dimension of the wall is 6 meter. Now this is in twin dimension. We have the wall thickness 230 mm or 0.23 meter. This wall thickness is same for all the walls appearing in the drawing. So center to center distance for ward will be, vertical wall of the ward will be 6.23. Now there are 3 vertical walls. As I have highlighted in the figure here, there are 3 vertical walls. So 3 into 6.23. Now there is also a vertical wall between medical store and consulting room. The vertical dimension of that wall is 4 meter. So center to center dimension will be 4.23 meter. So this is how we get the total center to center distances of all the walls appearing in the vertical direction. Here, when you are calculating the center to center distance, do not consider the doors and windows. You have to consider that there is an entire wall, because we are finding it for excavation. So the door is not at the excavation level. So we need to excavate the entire wall. You cannot think like that, sir, here there is a door, so we cannot calculate this that much dimension. No. You have to calculate the entire wall for the excavation purpose. I hope that is a point of common sense and you are very clear about it. Now, talking about the horizontal direction. So in horizontal direction, as you can see at the topmost part of the plan, the horizontal direction is made up of 3 components: ward, medical store and the consulting room. So the horizontal dimension of the door is 3 meter. So center to center 3.23. Then the horizontal dimension for the consulting room is 4 meter. So center to center 4.23. Then the horizontal dimension for the medical room or medical store is 3.5. So center to center 3.5 plus 0.23, that is 3.73. There are 2 major horizontal ones, top and at the top of the plan and at the bottom of the plan. And there is 1 semi-horizontal wall connecting the medical store and consulting room, as highlighted in the figure. There is a connecting that horizontal wall. The center to center dimension for that wall will be 4.23 plus 3.75. What I have done is center to center distance for the consulting room in horizontal direction and center to center distance for medical store in horizontal direction. So let us write all the center to center distance which we have just discussed. So as we have discussed, these are the horizontal center to center distance and the vertical center to center distance. So the total center to center distance we will get as 53.26 meter. Now this is our first step. Now second step of the centerline method, we have not started the quantity calculation yet. Mind well, we are doing just a fundamental calculation of the centerline method. So the second step is to calculate the number of junction. So as you already know, to find out the total junctions appearing in the drawing, we need to draw a line diagram for the entire drawing, and then we need to highlight the T and plus shapes in the drawing. That if there is a plus shape or the plus junction, we need to consider as 2 T junctions. So let us prepare the line diagram. So here is the line diagram of the given drawing. Now let us highlight the junctions. So as you can see in the entire drawing, there are 6 T junction and there is no plus junction. So the total number of junctions will be 6 T junctions. So I hope we are clear about the total centerline length and we are clear about the junctions. Now let us start the quantity calculation, and the first quantity which we are going to calculate is excavation or the earthwork for excavation in foundation. So let us see. So as we know that here there is no plane drawing. This plan is having cross walls. So we need to deduct the junction. So we need to calculate the net centerline length. Now the net formula for the net centerline length is net centerline length equals to total centerline length minus half into width into number of junctions. So in the case of excavation, the total centerline length is 53.26 minus half into number of junctions, that is 6 junction, and width. Now here the breadth or the width is the level at which we are working. So let us see the section. So as you can see in the section, we are working at bottommost part. So the width of the bottommost part is 750 mm or 0.75 mm. So we need to take the breadth or the width as 0.75. So the net centerline length will be 51.01 meter. That is only net centerline length. So the L is already there. Now we need to see about the width and height. So width and height we'll get from the section drawing. Let us look at again the section drawing. So as you can see in the section drawing, the width of the bottommost part, we are talking about the excavation. So excavation is the bottommost part of the foundation. So that is 0.75, and the height for the excavation is what? Below the ground level. So adding up all the heights given below the ground level in the drawing, we'll get 1.5 meter. So coming back to the quantity calculation, now we have the length 51.01, we have the width 0.75, and we have the height 1.5. And we have in the column of number I have written 1 because in center line method I have considered all the walls. I have considered center to center distance of all the walls. There is no wall remaining, so number will be 1. I have considered all the wall as the single. Now multiplying numbers, length, width and height. So we'll get the quantity of excavation as 57.39 meter cube. Here L was in meter, B was in meter and H was in meter. So the final quantity will be in the meter cube. The unit must be written with the quantity. You need to write the units with the quantity. And if there is a similar unit, you can write at the top where in the heading of the column where quantity is written. The second quantity is PCC, plain cement concrete in foundation, having ratio 1:5:10. Now here there is a common sense concept, students. Common sense, that at what part you are going to do PCC, in which area you have excavated, in which area you are excavating, in that portion you are going to do PCC. So the length, width and number are going to same as excavation for the case of PCC. So the centerline length will be the same in the case of excavation as for the PCC, 51.01. Width of PCC will be the same as of the excavation, 0.75. But only thickness of PCC will be changed. So let us see at the section what was the thickness of PCC. So as you can see in the section drawing, the thickness of PCC is 150 mm or 0.15 meter. So the thickness only will be thickness changed. Other dimensions are the same as the excavation. So the quantity will be 5.74 cubic meter. So that is our first two quantity. I hope you have understood it very well. If not clear, you can try to calculate by yourself. Have a calculator, have a note pen with you and try to calculate by yourself. Now moving forward with our third quantity, and that is masonry up to plinth level. Yes, the third quantity is masonry up to plinth level. So before we start talking about the quantity, let us look at the section first. So as you can see in the section drawing, all we have done is calculated the excavation area and we have filled up the PCC. Now above that there is a step footing. So we need to calculate the brick masonry for that step footing. So the first step footing just above the PCC is of 550 mm, above that 450, above that 350, and then there is the last step of 230 mm. So the quantity for first brick step in footing, the net centerline length will be 53.26 minus half into number of junctions 6 into width. Now we are working at the first brick step footing. The width was 550. So 0.55. So we'll get the length as 51.61 into 0.55 width into height. If you have closely look at the section again, the height was 200. So we'll get the quantity as 5.68 cubic meter. And so as for brick step footing second and third. Now talking about the fourth brick step footing, that is up to ground and the height is 0.75. You can check with the section drawing again. So we'll get the total quantity up to plinth as 23.07 cubic meter. So that is our third quantity. What we have done in the third quantity, we have calculated each brick step footing. In that, we have the formula for the net center line length, and the width and the height was taken from directly from the section drawing, and similar for all the four step footing. So that is how we'll get the total quantity as 23.07 cubic meter. But here we are forgetting something. What we are missing? Let us see. Yes, the steps. As you can see, we are missing the steps. In the question, the sentence was written that we need to assume that the steps are constructed in 1:6 masonry and having the BBCC foundation below the ground level. So the step were constructed. So that means the foundation was. We have to assume that the foundation is prepared by BBCC, but the steps are there, as you can see also in the plan. So the steps will be look like this from the side view. So we need to calculate for the steps also. Now for the steps, let us discuss the L, B and H length. Going back to the section. As you can see in the drawing, the length of the door is same as equal to the width of passage, or you can see the opening schedule of the door. So for the steps, the length will be 1.77. Now talking about the width, as you can see in the drawing, at the bottommost part is having here that there are three steps. So each the riser and thread dimensions are given 0.15 riser and 0.30 thread. If it is not given, these are the generalized dimension which we need to assume for the steps. So 30 is the thread. So at the bottommost, it is consist of 3. So the 0.30 into 3. So the bottommost part will be of 90. Above that there will be 16. Above that there will be 30. And the riser is 0.15. So that is how you can calculate the quantity of steps. I hope we are clear about the steps. Now this quantity is to be added into the previous quantity of 23.07. So we'll get the total quantity as 23.55 cubic meter. Now the last quantity is of RCC coping. General RCC coping is a band of an RCC in between the wall. So as you can see in the section that there is an 100 mm thick RCC coping, but students, RCC coping is being calculated in meter square quantity. So we have the thickness of the wall 230, that is our B, and the L is we can get from the net center line length formula. So the quantity of the RCC coping will be 12.09 meter square. Here the unit is meter square, that is in two-dimensional quantity. Don't write meter cube in the flow. Keep in mind. So I hope we are clear about the first numerical based on center line method. Here we have assumed that the step footing is constructed of BBCC below the ground level. But now what if there is an actually separate footing for the step? Let us see a new concept. So the next new concept is the calculation of steps having a separate foundation. Yes, the building is having its own footing. Now we are calculating the sum where the steps is having their own footing. So the question is, calculate the quantities of the following items for steps shown in figure: earthwork in excavation, PCC in foundation, and brickwork for steps. So we need to calculate the quantities for the figure. We are going to see the figure now. So let us see the figure. So as you can see in the figure, a plan and section of the steps is given. There are 3 steps constructed having 30 centimeter as tread and 15 centimeter as riser. The length of the step is 2 meter, but a dotted line is represent around the steps, and that there is in return that there is a portion of concrete. So why it is that generally students, when you are constructing the steps with the brick masonry, it need a strong base. So that base of the concrete is little extra. So this dotted line is representing that extra portion for the footing of the steps. So the original width of the step is 2 meter and the dotted length of that step footing is 2.2 meter. So there is a 0.1 extra at each side. Now talking about the section drawing, as you can see, the footing is of 50 centimeter at below, and there is a small strip. Look at the section closely. There is a small strip given at below the steps. So that is the footing of the step, and that footing is slightly inserted into the wall appearing from the or common footing. That the common footing is going vertical, a wall is going there, and there is a slightly insertion of 2 centimeter of the step footing. So the width of the footing, as you can see in the section, the width of the footing is 1 meter, tread is 30 and riser is 15 centimeter. So we need to calculate the excavation, PCC and the brickwork quantity for the steps given in this figure. So starting our solution with the length and the width of the steps. So for earthwork in excavation, length will be equal to total distance from the both dotted line shown in image. So L equals to 2.2. Now for width, you need to understand this concept. Width is calculated very differently. Let us see. So as you can see, this is our virtual representation of the section. I have enlarged the section. I have redrawn the section with the help of lines and lines in the PowerPoint. So this is our section. Now first you are going to excavate at the bottommost part, the bottommost footing. So while you are excavating of that 50 centimeter footing, you are technically excavating this much area. Now as you can see, as I have highlighted, in that area, that certain part of that footing strip of the step, that the step footing of the step is slightly covered in that area. So while calculating the width, we need to deduct that part because that is an overlapping with the original footing. So we cannot excavate 2 times there. Excavation cannot happen 2 times. It is an overlapping. So we need to deduct that common part from the width. So the original width of the step footing is 1 meter. The common base footing is of 0.5 meter. The wall thickness is 0.3 meter. So this was 0.5. From that 0.5, 0.3 meter wall is appearing. So if I deduct 0.5 minus 0.3, I will get the remaining amount as 0.2. But the steps are only on the one side of the footing. So I only need to deduct of the one side. So 0.2 was of the total. So I need to deduct only from one side. So that is 0.2 divided by 2, that is 0.1. So we got the answer as 0.5 minus 0.3 divided by 2. So whenever there is a footing for separate strip footing is given for the steps in the drawing, we need to change our width. We can't take our original width given in the drawing. We need to deduct this common part. How we can deduct? There is a simple general formula. Bottom width of the footing minus wall thickness divided by 2. You will get your answer. So our B will become 1 minus this 0.1 common part. This is the value of this common part. We need to deduct it from the original width. So B will be 0.9 meter. Now let us calculate the quantity. So the quantity for the earthwork in excavation is numbers are 1, there is only one step. Length is 2.2, width we have just discussed 0.9, and the height in the section is given 0.1. So 0.198 cubic meter. Now for PCC, let us revise that section. Now closely look at this section. The footings PCC is going to be here, and the steps PCC is going to be here. So there is no common part. So now we need to take the width as original width. Yes, because the bottom PCC is going to be here, and the strips footing, that footing is going to be here. So there is no common part in PCC. There was only common part in excavation. So here the original width of the step will be 1.02, and the thickness of that footing is 0.1. So we'll get the quantity as 0.224 cubic meter. I hope we are clear up to this point. Now the third quantity is brickwork. So now as you can see in the figure, that is a 3D representation of the steps in which dimensions are written. Let me redraw the section. So there are 3 steps looking like this. The bottom will be of 90 centimeter having 3 threads. Above that 60 and above that 30. The riser is 0.15. The length of the step is 2 meter. 2.2 was with concrete. Now I am talking about the steps only. That is only of 2 meter. So now let us calculate the quantity. So as you can see, there are 3 steps. First, second and third. The length will be 2 meter. For bottommost step, 0.9 width. Height is about of riser. Then 0.6 into 0.15. Then 0.3 into 0.15. So that is how we'll get the quantity of brickwork as 0.54 cubic meter. So I hope we are clear about the concept of center line method. So this is it. That was all about in today's session. What we have learned in this session, we have done a numerical based on center line method, and then we have learned a concept that if there are brick masonry steps are given and that steps are having a separate footing, how to calculate that. So in case of any query or doubt, you can always contact me on my mail or my number. Thank you for watching this.